After creating the knowledge base, the next step is to describe the entities of reality by means of GeneXus objects. To identify the entities of reality, we recommend paying attention to the nouns mentioned by users. At the travel agency that asked us for the application, they told us that they need to register their customers, the tourist attractions they usually propose to visit, as well as the countries where these attractions are located. From this, we identified these three entities of reality to be described in the knowledge base. For each identified entity of reality, we will create a GeneXus object of transaction type. The first GeneXus objects defined in a knowledge base are transactions, since they are the ones that allow us to describe the entities or actors of reality. Let's go to GeneXus to do it. To create a GeneXus object, we go to File, New, New Object. We see that objects are grouped into categories to make it easier to find the type of object we want to create. Within data management, we select the transaction type. We'll name it Customer and leave it in the root module of the KB. We click on the Create button. In the central window, we can see the transaction open for editing, ready for us to start defining it. Every transaction that is created will include these sections, which we'll explain in due course. We'll start with the Structure section. The structure of a transaction allows us to define the relevant attributes of the entity of reality. For each customer, we want to register their first name, surname, address, telephone, and email. So, name, last name, address, phone, and email will be the relevant attributes of the customer entity. By pressing Enter here, we see that a first line is created to define the first attribute. And notice that there's a key icon associated with this line. This is because in every transaction, it's required to define an attribute or a set of attributes with the role of identifier or key. The concept of an identifier or key is so important that it is not possible to create a transaction without an attribute playing this role. It is the one that will allow us to uniquely identify each specific instance of the registered entity. In our case, each customer. In reality, people have a legal identifier, which is their identity document. Therefore, we could choose as the identifier attribute of the customer entity, one that represents that value. But if the travel agency doesn't need to store that information, then we'll have to define a custom identifier attribute, which will only identify the customer within this system. We'll call it Customer ID, short for Customer Identifier. By pressing the dot key, GeneXus writes the name of the transaction as a prefix in the attribute name. Then we complete its name with id. When we leave the field, we can see that the type column displays the data type that this attribute will store. By default, it has chosen this numeric value of 4 digits and no decimals. This means that the customer id attribute will be able to store numbers from 0 to 9999. If we expand this combo, we can see the data types offered by GeneXus. For customer ID, it makes sense to keep it numeric. We press Enter and then we'll define the second attribute. Again, we type a dot and complete the attribute name with name. That is, customer name. The data type of the attribute that will store the customer name will clearly not be numeric, but rather a type that represents strings of letters, such as these 3. For example, the data type varchar, which stores variable length text values. Note that the default length is 40 characters and we'll leave it that way. It means that it will store up to 40 characters. Using the same process, we enter the customer last name attribute, the customer's last name, which will also be of type varchar. Note that we can start typing it, and a list of matching suggestions will appear. I choose varchar. Now we define the customer address attribute, the customer's address, and we see that in this case the automatically assigned data type was not numeric. Since there is a data type for storing addresses called address, and we gave the attribute a name that ends with that same word, address, GeneXus assumes we want the attribute to have that type. With the next attribute, customer phone, the customer's phone, the same thing will happen. And also with the last attribute, customer email. Notice that we're shown this mark next to the customer object name. It indicates that the transaction is being edited, and when we save the changes with File, Save, or Ctrl+S, the mark disappears. We can also see that this flag was added for the customer name attribute. This indicates that of all the attributes, it is the one that best describes the customer. Later, we'll see what this role is useful for. Once saved, the object becomes accessible from the KB Explorer. For example, if we close it, we can open it from here with a double click. It opens in the source section, which, as we can see, was automatically modified by GeneXus to reflect what we did in the more specific Structure tab. This window is less graphical than the other one, but it allows us to do the same. If we collapse these sections, we can see the transaction structure definition using this syntax. Here are the attributes, and here are their data types. If we notice that an attribute has no data type, I is because it uses the default, numeric with 4 digits and no decimals. Now let's observe that what was represented in the Structure tab by the key icon here is represented by an asterisk. And what in the Structure tab was represented by this other icon to indicate the descriptor attribute here is represented by an exclamation mark. These two tabs are synchronized. What you do in one is reflected in the other, because they are two different ways, one based on code and the other graphical, to work with the transaction structure. In the Source tab, it will be possible to do more things, as we will see later. Now, if we switch to the Web Layout tab, we can see that GeneXus automatically designed, according to the defined structure, a web form, so users can insert modifications and deletions of customers in the database. Do you see that all our attributes appear in this layout as controls? This transaction object will be converted into an executable program, which will include a screen for these interactions. We'll cover that in the next video. Let's go ahead and see what it looks like at runtime. Recapping what we've done. We created a transaction object to represent an entity of the reality that our application will model, and we defined the attributes of that entity. Based on them, a web screen was automatically modeled, allowing the user to manipulate the information. But where will this information be stored? In a database table that will have the same name as the transaction. So if we locate the transaction in the KB Explorer, we'll see that GeneXus automatically shows it has an associated table, customer. If we open the table object, we can see its structure. It will be identical in this case to that of the transaction. And what was the identifier in the transaction? Here will be the primary key of the table. This information we see is logical, not physical. The table has not yet been created in the database, nor do we yet have a program to execute this transaction. When the table is actually created in the database, it will have this structure. The fact that the customer ID attribute is the primary key of the table means that there cannot be two records in the table with the same value for this attribute. There can only be one customer with ID 1, only one customer with ID 2, only one with ID 3, and so on. However, there may be two customers with the same first name, or the same last name, address, phone number, or email. In the next video, we'll ask GeneXus to build both the database and the table, as well as the programs needed to make the transaction executable and start testing.